Hi, this is Math with Townsend, and I'm Miss Townsend. We're talking about the Grade 9 Academic Analytic Geometry Summative. This is question 1b. For what values of k are the lines blah 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 and blah 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 perpendicular? Well, those lines should look familiar to you because they're the exact same lines that we studied in question 1a. In fact, if you haven't already done question 1a, stop right now and go do 1a, because I'm going to be taking some shortcuts that won't make sense if you didn't see what we've done in question 1a. Since those lines are familiar, let's talk about the thing that's new, and that's the word perpendicular. So we're talking this time about perpendicular lines. And I know that if I asked you, what does it mean to say that lines are perpendicular? A lot of you would say this. Perpendicular lines have slopes that are negative reciprocals of each other. Now that's some pretty fancy vocabulary, but we know what that means. It means if I give you a slope like this, you need to take the reciprocal, which means flip it upside down, and you need to make it negative, and that means you change the polarity. The original slope was positive, so the perpendicular slope has to be the opposite, so it has to be negative. That's what perpendicular lines are. And that's great, but there was another definition that we looked at when we studied perpendicular lines, and it's more important for this question to review that particular definition. So here it is. Perpendicular lines have slopes whose product is -1. So if you take their slopes, multiply them together, and your answer is -1, then you know you have perpendicular lines. For example, if we take the two slopes we just talked about, 2/3 and -3/2, if I multiply them together, I'm going to get -6/6, which is, of course, -1. So that's another way of thinking about perpendicular lines, and it's important that you know both methods. So let's look back at the question. We know again that this is a question that has to do with slopes. So let's talk about slopes. Here's line 1, here's line 2, and again in question 1a we found both those slopes. So the slope of line 1 we know was 3k/7. And the slope of line 2 was -2. So if I want to think about negative reciprocals, that's kind of confusing. Because these two numbers, 3k/7 and -2, there's nothing in common. And I can't even figure out how to flip one and change the sign. That's a little confusing to me. So let's talk about the other definition of perpendicular, which is that if I multiply the slope of line 1 times the slope of line 2, my pen is having problems. If I get -1, then I know that I have perpendicular lines. So let's set up that equation. Here's the slope of line 1. Here's the slope of line 2. I'm going to make them equal to -1 because I want these lines to be perpendicular. And if you look at what I have, this is a simple one variable equation where I can solve for k. It's a little messy, but that's all it is. So let's do that. Let's solve for k. So I'm multiplying. So 3k times -2 is -6k. 7 times 1 is 7. That equals -1. Keep going, solve for k. Multiply both sides by 7. Solving for k, I'm going to divide by -6. So k equals 7/6. So that means in that original equation for line 1, 3kx minus 7y minus 10 equals 0. If I substitute 7/6 for k, this line would be perpendicular to the other line. That's it. All done.